Hey everybody, we're going to do a little example problem here from the lab. And we started off with a temperature of 80 degrees Fahrenheit. And after swinging the sling psychrometer, we got the temperature to drop down to 76 degrees Fahrenheit. Unfortunately, Fahrenheit's no good. We have to convert it into degrees Celsius. So I did that for us, and we just used the little formula here in the in the lab, and basically plug 80 degrees into here to get the right temperature. So I took 80 degrees, put it in here, subtracted 32 from that, so I got 48. Multiplied that times 0.556. And I got a temperature of 26.7 degrees Celsius for the dry bulb. Did the exact same thing over here for the temperature of the wet bulb, and I got 24.5 degrees Celsius. Okay, so we know basically what happened here is we, put a little gauze on the end of a bulb. I'll show you a video of that later. And swung it around and let the water evaporate. Now, the more rapidly the water evaporates, the lower this temperature is going to be for the wet bulb. If the air is already close to saturation, that means it can't hold any more water, and this isn't going to go down very much. Okay? So let's try to find out how much water 80 degree Fahrenheit air can actually hold at the maximum before it starts to rain and come out. So if we go down to this chart, of course it's not in Fahrenheit, it's in degrees C, so we need to use this. It's 26.7 degrees. So I'm going to go over here and use this little drawing thing. Actually, let me get a smaller dot there. Okay. So if I come down, see if I can get rid of this thing, and I go to 27 degrees, these are 2-degree increments, that's 22, 4, 6, 8, 30, so 22, 24, 26, almost 28, so right about there is what my temperature is in degrees Celsius. So now what I got to do is see where it hits this curve. So I'm going to take this line and I'm just going to go all the way across here like this and touch the curve. Looks like right about there on that line. So then I can take this and go down, and it looks like 26 is the magic number. And what does that 26 represent? That's how many grams of water per cubic meter of air, okay, can hold. So 26 grams of H2O for every cubic meter of air. That is a decent amount of water for 1 cubic meter of air. So it can hold a lot of water. And if it does have this much water in it, it can't take any more in. And water will start to precipitate out in the form of dew or rain. It's not going to be able to hold any more than that. Okay, so that's the maximum that it can hold. Now, let's go back up here and take a look at what our temperature difference is. So 26.7 was the dry bulb, and 24.5 degrees C was the wet bulb. So the difference between these two temperatures, the temperature depression, is going to equal 26.7 minus 24.5, and that's going to give me 2.2 degrees C. Okay. So what is that going to give us for relative humidity? So now we have the temperature depression, 2.2 degrees C. We know how much water 80 degree Fahrenheit air can hold, or 26.7 degrees C air can hold. So we go down here and we just go, wow. Temperature of the dry bulb in degrees C. It doesn't give us decimals, but it would round up to 27 degrees. Okay, so that's our number there. And then in bold here, underlined, that's the temperature depression. So for us, it was 2.2, and that's just going to be closest to this number here. So if we go down on the bottom here, these numbers represent the relative humidity percent. So all we have to do is go, okay, here's this column right here with the approximate 2 degree temperature depression. And then we just come down in this column, and this number right here that corresponds with this is going to be our relative humidity. So relative humidity, RH, for that particular example that I gave, is going to be 85%. Okay? It's pretty humid. The temperature didn't drop very much, so when the sling psychrometer was spinning around, we only got the temperature to drop from 80 degrees down to 76 degrees. So the air was already fairly full of water. That's why it didn't go down as much as it could have. So 85% relative humidity, pretty wet out. All right, so let's go down here and figure out what the dew point would be for our example. Hey, we're back to Fahrenheit again. Okay, so let's look at based on our 85% humidity, what is the dew point? So what this means is, as the temperature drops, the amount of water that can be held in the air also drops. So we take say a cubic meter of air and we start to cool it down. Eventually, the water that's in that cubic meter of air is going to come out in the form of precipitation. It could either rain, or it could just make dew, which is just the water that kind of coats everything in the morning sometimes when you wake up and the grass is wet, that kind of thing. Okay? So we had 80 degree Fahrenheit air, and we had a relative humidity of 85%. So if we go along this line right here, I'll just sort of underline this. We go all the way out to 85%, which is right there. Then I go straight up from here to figure out at what temperature would the water come out of 85 degree air, and it looks like it's going to be 75 degrees. What does this all mean? Okay, well, if I have 80 degree air with an 85% relative humidity, the air temperature only has to drop down to 75 degrees for that air to no longer be able to hold water in the vapor phase, and it comes out in the form of liquid water and makes dew, okay, and it makes the grass wet. We could look at another scenario. Let's just say we had 80 degree air, say it was in the summertime in Chico, and the relative humidity was only, say, 16%. Okay, super dry air in, just a few weeks ago at the beginning of November. it was like this, very, very dry. So 80 degrees, only 16% relative humidity. What would the air temperature have to be for that water to come out? Well, we would go straight up here again and find out that the air temperature, and this is in degrees Fahrenheit, would have to be down below freezing, 30 degrees, before any moisture would come out of that air with only 16% relative humidity. So that's what the dew point is all about. So the drier the air, the lower the dew point has to be. If it's wet air with a high relative humidity, then we're gonna, be able to get that water out when the temperature only drops a little bit, in this case down to 75 degrees. Okay, so that's how we use these charts to figure out the dew point, temperature, and to find out the relative humidity. So I'm going to show you a video of some other guy spinning a sling psychrometer, and you guys are going to do this for yourself. So we need these 3 diagrams. They're all going to be in the lab, and hopefully this video will help you figure out how to do the temperature conversion. Okay, converting from degrees Fahrenheit to degrees Celsius by basically plugging it into this formula, and then using these 3 charts to answer the questions. All right, good luck.